Hi, in this video we're going to talk about the Richter scale. So this is the scale that measures the size of an earthquake. So this one we may be very familiar with living in California by listening to all the earthquakes that have happened in the past. So what is the Richter scale? So these geologists define the magnitude of an earthquake to be the log base 10 of I, the intensity of an earthquake, divided by the standard intensity of an earthquake. So let's define what these things are. So M is the magnitude, and this is what is the Richter scale. So in here, magnitude 8.3, 6.6, so that is already applied to log base 10. I is the intensity of the earthquake, and so this intensity is measured from 100 kilometers away approximately from the epicenter of the earthquake, and this intensity is the amplitude of the seismograph. So in the intensity, so we're going to say measured approximately, so about 100 kilometers away from the epicenter. And this is measured in centimeters. And it is the amplitude. So let me see here. The amplitude of the wave in a seismograph. So you may have seen some seismographs and they have the waves, and I have an example of what that looks like also. And S is the intensity of a standard earthquake. And this is defined to be 1 micron, which is 10 to the minus 4 centimeters. So that's why I said measure in centimeters, or sometimes this is measure or in microns, depending on how big or how small it is. So here's an example of the Richter scale graph, a graphic representation of what the scale tells us. So a 0 is essentially the standard earthquake. There's really no earthquake. And then 1, 2, 3, minor, 5, small, 6 is now moderate, and you start to get some damage. And then 7, 8, and keeps getting higher. And so this is an example here of a seismogram. So when I say that the intensity in the formula here, the intensity measures the magnitude, measures the amplitude of the wave in a seismogram. This is what a seismogram wave looks like. So the amplitude. So if you've taken trig already, your sine curve and your cosine, the amplitude is measured from 0, 0, and then to the top of the graph, and then to the bottom of the graph. So same thing here. So you have all this waves, and the amplitude is that distance from the middle of the wave to the top of the wave or to the bottom of the wave. And so that's what the intensity is measured. So let's try an example. We're going to take a look at the 2010 Haiti earthquake, and we're going to try to find the intensity for that earthquake. Okay, so in 2010, the Haiti earthquake had a magnitude of 7.0 in the Richter scale. So we want to know, what is the intensity of the earthquake? You might remember the earthquake in Haiti. So we're going to use the formula for the Richter scale. The magnitude is equal to the log of the intensity of the earthquake. We'll measure in centimeters, approximately 100 kilometers away from the epicenter, divided by S, the standard intensity of an earthquake. So let's plug everything that we know. So we know, what do we know? M is equal to 7. We're looking for the intensity, and we know S. We always know S. S is 10 to the minus 4 centimeters. Let's plug everything in. So I'm going to have 7 is equal to the log of I over S, 10 to the minus 4. So I have a logarithm, and this base 10. We can change it to an exponential by saying 10 to the 7 equals I over 10 to the minus 4, and so for I. Solving for I means getting rid of the 10 to the minus 4, so multiply both sides by 10 to the minus 4. So that here they divide out, they cancel, and I'm left with 10 to the minus 4 times 10 to the 7. I'm multiplying the same basis, so we add exponents, so 10 cubed equals I. And now 10 cubed is something that we can compute. I equals then 1,000. So what does this mean? This means that the intensity was 1,000 centimeters. So the amplitude, going back to looking at if you look at a seismograph, the amplitude will be 1,000 centimeters. So it makes sense that, notice that 7 is way up here. That will be considered a very destructive earthquake. And of course, anything higher than that. The Chile earthquake of 1960 had a magnitude of 9.5, so that would be interesting to see what the intensity of that would be. So what this means is the amplitude of the seismograph reading is 1,000 centimeters. So that's pretty big. So let's try another example. So let's compare the two earthquakes that we see up here on this graph. So we have the San Francisco earthquake of 1906 and the Chile earthquake of 1960. So those are two earthquakes that have gone down in history as being the largest. Actually, the one in Chile is the largest recorded in the world so far. So we want to know how many times more intense was the Chile earthquake than the San Francisco earthquake. Okay, so we want to know how many times more intense was the Chile earthquake than the San Francisco earthquake of 1906. So for this, because we want to know how many times more intense was one than the other, we want to take a look at the ratio of the two earthquakes. So I want to consider the ratio, and I'm going to say I, the intensity of the Chile earthquake over the intensity of the San Francisco earthquake. I'm going to define my variables here, intensity of Chile and the intensity of San Francisco. Because looking at the ratio is going to allow me to see how many more times the Chile was larger than San Francisco. So that means that we need to find the intensity of both of those. So just as we did before, I'm going to take my magnitude, my Richter scale formula, m equals the log base 10 of I over S, and I'm going to do it for both. So for Chile, I'm going to have the magnitude was 9.5, so it's going to be 9.5 is equal to the log of the intensity of Chile over 10 to the minus 4. And so I'm going to be able to solve. So I'm going to change it to an exponential. So it's a log base 10, so I'm going to have 10 to the 9.5 is equal to I, the intensity Chile, over 10 to the minus 4. Again, multiply both sides by 10 to the minus 4. So I'm going to have the intensity of the Chilean earthquake was 9.5 minus 4, so 10 to the 5.5. And I do the same thing for San Francisco. The magnitude of the San Francisco earthquake was 8.3 on the Richter scale. So I'm going to have 8.3 is equal to the log base 10 of the intensity of San Francisco over 10 to the minus 4. And we do the same thing, change it to an exponential. So 10 to the 8.3 equals I San Francisco over 10 to the minus 4. Multiply both sides by 10 to the minus 4. So you're essentially subtracting 4 from 8. So the intensity of the San Francisco earthquake was 10 to the 8.3 minus 4, so to the 4.3. So this gives us the intensity, which notice those are really big numbers. So how much bigger is one than the other? We want to look at the ratio. of I, the Chile, the intensity of Chile divided by the intensity of San Francisco. So what this means I have is 10 to the 5.5, the intensity of Chile divided by the intensity of San Francisco. And when we do that, if we're dividing the same basis, therefore we can subtract the exponent. So I have 10 to the 5.5 minus 4.3, so that gives us to the 1.2. When we put that in our calculator, we get 10 to the 1.2 is 16. So that means that the 1960 earthquake in Chile was 16 times larger than the 1906 San Francisco earthquake. And so this is by comparing the ratios. So when you want to know just how much larger was one thing over another, look at the ratio of the two. And this helps us. So 16 times larger. And notice that that makes sense. This is a logarithmic scale of base 10. So when I'm looking at from 8.3 to 9.5, so because it's a logarithmic scale base 10, just going from even just 8.3 to 9.3, that would have been 10 times larger because I'm going up one base 10, right? One unit in the Richter scale is, because we're using log base 10, it will be 10 times. So from 8.3 to 9.3 will be 10 times. So that means that then going from 8.3 to 9.5 has to be slightly larger than 10. So in this case, we get 16. And yeah, so then by looking at this, going back to this graphic representation, when you have, let's look at 6, a moderate earthquake. So in the Richter scale, magnitude 7 will be 10 times larger than an earthquake of magnitude 6. On the Richter scale, an earthquake of magnitude 8 will be then, so you went 2 tens, right? So it's 10 squared, so 100 times larger. So a moderate earthquake, magnitude 6, right? A magnitude 8 earthquake means is 100 times larger than a moderate earthquake. And so when you're over here at 9, a magnitude of 9, and remember the Chile earthquake was 9.5. So if you're a magnitude of 9, how much larger are you than a magnitude 6 earthquake? So that would be, you've gone 3 tenths, right? 10 cubed. So that would be 1,000 times larger than a moderate earthquake. So that's why when on the Richter scale, the higher the magnitude, the stronger the earthquake and the more devastation that you have. So that's how logarithmic scales allow us to talk about things, in particular in this scale. Earthquakes, the numbers keep getting bigger and bigger. So when we're talking about, like I said, from a moderate earthquake to something in a 9, that's 1,000 times bigger. But when you look at it, going from 6 to 9, it doesn't seem that big, but it's actually huge, the difference. Email me and let me know if you have any questions.